Hello students. So we're going to start this function study. We're going to start with polynomials on this lesson. I've taken lesson 1 and I've actually broken it up into 3 smaller videos because if I did one it was just getting way too long. So I've broken it up into equations, graphs, and characteristics. So the big idea with our function studies is we take a pattern, and the pattern you see by plotting a bunch of points, and then you're going to see on the graph that it fits a certain pattern, and each pattern that we look at has a name. So somebody a long time ago in history had discovered these patterns and they put a name to them. And the amazing thing is that these patterns that we've turned into functions, they actually model things in life. So what we're going to do with each of these types of functions is we're going to go over their graphs, their equations, and all of their characteristics. And then we do modeling problems. So we take sets of data, and when we plot the data that forms this type of a pattern, it's letting us problem solve and figure something out in life. So the polynomial functions is the first one. So it's a family of functions. And so you can think of it as like your own family, right? So in your family you have each person, and they're different, but they all fall under your family. So polynomials is a family of functions, and each function looks a little different. They have their own personality, and the personality are those characteristics. So what we're going to look at for each function is what does it look like and what is its personality. All right, so polynomial functions. There are 3 polynomial functions that you're responsible for knowing in Foundations 30. A linear function, which is the one that you did the pre-teaching when you looked at those videos and you plotted points. It's a line. The second type of polynomial function is called a quadratic. And the third type is called a cubic. So for each of these, we're going to look at their equations and what makes it a polynomial and what makes it this particular kind of polynomial. We're going to look at their graphs because they all look very different. They each have their own personality. And then we're going to look at those characteristics and put names to them and identify them. Okay. So this lesson is going to start with the equations. So it'll be a little bit shorter, and then we'll do the graphs, and then we'll do the characteristics. Okay, so you have this in your packet. So if you go to the notes packet that I photocopied for you, you have this table. And this is your keep in mind that is in your workbook. It gives you, it's a really good reference point because it gives you the picture of all the functions that we're going to study in Foundations 30 for polynomials. It gives you their characteristics, which we'll do that in the 3rd video. So it's a really great resource for you to go back to. All right, so we're going to tackle the equations first. And so the page in your notes has this in it. This isn't in your book. It talks about polynomial functions and how do you know it's a polynomial? So that's the first thing we want to tackle. From the equation, we're going to start with why is it a polynomial? So you have some bullet points up at the top. The first 3 bullet points are going to allow you to determine if the function is a polynomial from the equation. Okay, so these speak to the equation. The second 2 will speak to the graph, and how do you know graphically with the picture in front of you, how do you know that it's a polynomial? All right, so numbers 1 and 2, you have a bunch of polynomials and a bunch of non-polynomials. So what we're going to look at is these first three bullet points and look at how is it that these are polynomials in reference to those 3 bullet points, and how are these not? So the 3 bullet points are the sum of 1 or more monomials. So a monomial, so if you think about the word mono, it means one, a single expression. So you're going to add or subtract. Subtract is like adding, it's adding a negative. So we're going to see potentially more than one single expression added. That's how we could tell it's a polynomial. The coefficients must be whole numbers. Well, coefficients are numbers that are in front of those x values. So for example, if you have 3x, 3 is the coefficient. And then exponents must be whole numbers and not negative numbers. So the exponents are those little values in the top, so that would be a squaring. So you would have done squaring, you know, it's anything times itself. If you cube something, it's anything times itself 3 times. Right? So those are the exponents. So exponents must be whole numbers and not negatives. Coefficients should be whole numbers, not always though. And you have to have sum of more than one monomial, or you would have sum of one or more monomials. Okay, so let's take a look at, let's start by taking a look at why they're not polynomials. Not polynomials. So the first part, A, y equals x to the negative first. You have a negative exponent, not a polynomial. It's a different type of function. It is a function, but it has its own name. It's a different name. It's not a polynomial. Part B, y equals x to the 3/2. You have a fractional exponent. Again, not a polynomial. C, well, you just have a lot of letters, right? This is called a sine function. This actually is a very specific family in its own. It's called a trig function, a trigonometric. We studied that one last. And then y equals 1 over x. The problem here is that the x is being divided. So you can think of it, it's in the bottom of the fraction, right? And that makes it not a polynomial. And then part E, your exponent is a variable. It's not a constant number. So that makes it also a different family. It's a different family of functions, and this is called an exponential. We study those as well later. Next one. So those are all not polynomials, and that's how they're violating one of those first 3 bullet points. So if we go over to the ones that are, really just to highlight, you could probably look through them and make sure that you understand how they're polynomials. You should see the exponents are whole numbers. You have single terms being added or subtracted. And just to point out one thing that'll come up a lot is when you see, so the x squared, it's easy to see that that exponent is a 2. But if you have something like 3x, and you're probably thinking, well, there's no number in the exponent. There is an exponent there, it's 1. You just never will see it written. It's assumed to be there. So 3x, it's to the first power. And of course, 1 is a whole number, not negative. And then these numbers that don't have any x's on them, any of those variables on them, they're called constant terms. And a constant term, you could think of it, although again, you're never going to see it written like this, but it could be written as x to the 0. Okay, but we don't write that. You don't see it published in a book. We just know that, well, if I need to know what the exponent is 0. But 0 is a whole number, not negative, so it doesn't violate the rules. Okay? So these are the equations. So what I've done is I just have 4 here so you can test yourself real quick on this concept. Which equations are polynomial functions? So if you want to pause the video, write them down, and then write why if they're polynomial or not, and I'll come back and then I'll talk about them real quick. Okay, so the ones that are polynomials, part A is a polynomial. I have a whole number, exponent. I have 2 monomials being subtracted. Part B is not a polynomial. The 1/2 isn't a whole number. It's okay that the number outside here is negative. It's the one that's in the exponent. Can't be negative. Part C is a polynomial. I have a positive whole number being added. And part D is a polynomial. I have 2 monomials, and this is to the power of 1. Okay, so that's the end of this lesson. The next one we'll go through is graphs of them, so you'll need to have your calculator.